All right, let's do it. Time for a deep dive into pseudocode. You know, a lot of you have been asking about that role of pseudocode in problem-solving article from the Algocami blog, so we're gonna tackle that today.
Yeah.
You know, when I first heard about pseudocode, I thought like, oh man, this is gonna be some super technical stuff. You know, only for like hardcore programmers. You know,
Yeah.
but
Yeah.
it turns out like it's really not. It's more like sketching a blueprint. You know, before you build a house,
Right.
it helps you plan out the logic of a program. You know, before you kind of get lost in the actual code. And get this, it's not even just for coding. It's used in all sorts of fields.
Yeah.
You know, even things like database
Yeah.
design or planning out,
Yeah.
you know, machine learning algorithms.
Absolutely. You know, it's amazing how our brains are wired, to look for patterns, to simplify things.
Mm.
And pseudocode really taps into that. It allows us to take those complex problems and just break them down into smaller, more manageable steps. It's like a roadmap for your thoughts.
So it's like it gives our brains a framework to hang those ideas on. No more mental chaos.
Exactly. You got it.
Awesome.
And the Algo Academy blog really drives home why this matters for problem solving. They list 5 key reasons. I think you'll find these pretty insightful.
All right, I'm ready. Hit me. Lay it on me. Give me the reasons.
Number 1, think about a time you've been coding and all of a sudden you're like, wait a minute, how'd I get here?
Oh, yeah.
Like, this code is a mess. I went down a rabbit hole. Now I gotta backtrack, Pseudocode can help you prevent that.
Oh, okay.
It forces you to think through that logic step by step before you write a single line of actual code.
Oh, okay. So it's like a safety net for your brain. So you can kind of spot those facepalm moments before they happen in the code.
Exactly. You spot it early on.
Yeah, that makes a lot of sense.
Oh.
What else does the blog highlight?
Well, they also talk about saving time. By planning ahead with pseudocode, you can actually avoid those painful debugging sessions later.
Right.
Where you're like, wait, why isn't this code working?
Oh, yeah, been there.
Spending hours trying to debug something when if you just planned ahead of time, you could avoid that.
Okay, so it's efficient too. I mean, that's
efficient.
That's great, especially if you're up against a deadline or something.
Yes.
Time is money.
Absolutely. Another one, communication.
Oh, okay.
Imagine trying to explain a complex algorithm to somebody just using code. I mean, that's confusing.
Yeah, that sounds like a recipe for confusion.
Yeah, it's a nightmare. But pseudocode, on the other hand, it's like this universal language that programmers can understand.
It's like a shared language that cuts through all the tech jargon.
Yeah.
That would be, that would be super helpful when you're like collaborating on a project or something.
Absolutely. And it leads to better planning.
Yeah.
With pseudocode, you can kind of lay out the entire structure and the flow of the program before you even dive into the actual nitty-gritty of the code.
Okay.
You wouldn't just start laying bricks without a blueprint.
Totally.
You gotta have the plan.
Having a plan is key. Can save you from a lot of headaches.
Exactly. And then the last one they mention is flexibility.
Yeah. So
whether you're coding in Python, Java, C++, MO, it doesn't matter. You can adapt pseudocode to any language.
So it's language agnostic.
Exactly.
Okay, you've convinced me pseudocode is awesome, but I have to admit I'm a little intimidated. I'm picturing myself staring at a blank page thinking, where do I even start? Are there any tips for writing good pseudocode?
Absolutely. The Algo Academy blog outlines 5 practical tips that I think are really helpful, and it really boils down to keeping it simple, consistent, and focused on the logic, not the tiny little details.
Okay.
It's like painting the big picture, not getting lost in the brushstrokes.
Gotcha. All right, well, I'm intrigued. I'm ready to dive into these tips. What's number 1?
Number 1 is keep it simple.
Okay.
Use clear and concise language that anyone can understand. You're not writing a novel, you're just writing a roadmap.
Okay. So no need to get fancy with the vocabulary or anything. Just really clear, straightforward instructions.
Yeah.
Okay, what's next?
Number 2 is be consistent.
Okay.
Use the same terminology and structure throughout your pseudocode.
Oh, okay.
Think of it like writing a recipe. You wouldn't switch from cups to ounces halfway through, would you?
Right. That would be a recipe for disaster.
Exactly.
Okay, so consistency in the terminology and the structure. Okay, got it.
Number 3 is don't underestimate the power of indentation.
Oh, okay.
Indentation visually shows you the structure, and the nesting of your algorithm. It's like an outline for a presentation.
Yeah.
The visual hierarchy just makes it easier to follow.
Totally. I am a very visual learner, so I totally appreciate a good visual hierarchy, right? So what's next?
Keep it high level.
Okay.
Focus on the logic and the flow, not the teeny tiny details,
Okay.
of the syntax.
Got it.
Or the specific language feature.
So don't sweat the small stuff. Just focus on the overall flow.
Okay.
What's the final tip?
Final tip is use common programming constructs.
Okay.
Things like loops, conditionals, functions.
Yeah.
This helps kind of bridge the gap between your pseudocode and the actual code that you'll be writing later.
So it's like you're speaking the same language even in the planning stages.
Exactly.
Okay, I see that. Yeah. Now the blog actually gives an example of finding the largest number in an array. They show the pseudocode and then they show its equivalent in Python.
Right.
It's really helpful to kind of see it in action.
It is. It's a classic example because it shows how you can really break down a problem into clear logical steps.
Okay, well, I'm ready to see that. Walk me through that example.
All right, so imagine you have a list of numbers, right? And you need to find the largest number in that list. In pseudocode, this might look something like this. First, you create a function, let's call it find largest number. And this function takes in your list as input. And then what you do is you set a variable, let's call it largest, to the first number in the list.
Okay, so you're starting with the assumption that the first number is the largest.
Yeah, for now. It's our starting point.
Okay.
And then what we're going to do is we're going to loop through each number in that list. For each number, we ask, is this number bigger than our current largest value? If it is, we update that largest variable to this new number. And then once we've gone through all the numbers, we simply return the final value of largest.
Oh, wow. That's surprisingly straightforward.
It is. It really is. And the beauty is you can then translate that logic into any programming language. So the blog shows how to do it in Python, for example. And you'll see it mirrors the structure very closely. It's like a blueprint that you can build on.
Okay, yeah. No, my mind's starting to grasp this now. It really does simplify things. But what happens when you're dealing with, like different programming styles, like object-oriented programming or functional programming?
Right.
Does pseudocode still work in those cases?
Absolutely.
Okay.
That's where it gets even more interesting. It's incredibly adaptable. You can tailor it to different programming paradigms. So, for example, let's take that same problem.
Okay.
Finding the largest number in an array. But this time, we'll look at it from an object-oriented perspective and then from a functional perspective.
Ooh. I'm curious. Show me how that works.
Okay. So, in the object-oriented approach, you might have, you might define a class. Let's say you call it number array.
Okay.
And this class has a property, maybe for a list of numbers, and then it has a method, a function, to find the largest number within that list.
Okay.
The logic inside that method would be essentially the same as what we just saw, but now it's organized within the structure of a class.
It's like you're packaging the logic neatly within an object.
Exactly. Now, from a functional perspective, you could use a function again, find largest number, but this time you might use a technique called reduce.
Okay.
To iterate through that list and find the largest number.
Okay. Hold on a second. Reduce.
Yeah.
Can you break that down for me a little bit?
Sure.
It sounds a little intimidating.
So reduce is a functional programming concept where you basically boil down a list of values into a single result.
Okay.
By repeatedly applying a function. In this case, the function would be comparing two numbers and returning the larger one.
Oh, okay. So it's like a tournament.
Yes.
Numbers are battling it out and only the largest one comes out. I like that analogy.
I like it too.
It makes it much easier to understand.
And that's kind of the key, right? It's about expressing these complex ideas in a way that anyone can understand.
Right.
Regardless of their, technical background.
Now, you mentioned earlier about tech interviews.
Yes.
Like, why is pseudocode so crucial in those interviews?
Yes.
Especially at, the big tech companies like Google or Facebook.
Oh, yeah.
Everyone wants to work there.
It's a secret weapon for those tech interviews, especially when you're aiming for those, those coveted roles.
Okay, spill the beans.
Mm-hmm.
Tell me why.
Okay, first of all, it showcases your problem-solving skills. Interviewers aren't just looking for somebody that can, churn out code. They want to see how you think.
Okay.
How do you approach a problem logically?
Right.
And pseudocode allows you to kind of reveal that thought process.
Yeah. It's like showing your work on a math problem. You're not just giving the answer, you're showing how you got there.
Exactly. It's about transparency.
Okay.
And showcasing those analytical skills.
Okay. So what else makes it a secret weapon for those tough interviews?
Well, it facilitates discussion. When you present your solution in pseudocode, it's much easier for the interviewer to follow your logic. They can ask questions, maybe suggest improvements. It becomes this collaborative process.
So it's not about having the perfect solution right out of the gate. It's more about like being able to communicate your thought process.
Exactly.
And then working together to refine it.
Yeah. It shows you can collaborate and adapt. Here's a big one. It helps you reduce the pressure.
Oh.
So imagine you're in this high-stakes interview, and they're like, all right, write this code, Having to write perfect, syntactically correct code right there on the spot, it can be nerve-wracking.
Yeah, that's a lot of pressure.
But if you start with pseudocode,
yeah,
it takes some of that pressure off. You focus on the logic, and then, if needed, you can translate that into the code later.
Oh, that's a big relief.
Okay.
I'd much rather showcase my thinking than worry about, like missing a semicolon or something.
Exactly.
Okay. What else? Anything else?
One more thing.
Okay.
It demonstrates your planning ability.
Okay.
It shows that you don't just jump in and start coding randomly. You actually take the time to plan.
Right.
And structure your solution.
Makes sense.
Which is a really valuable skill.
Yeah.
In software development.
So pseudocode is basically painting you as this thoughtful, organized, and collaborative problem solver. Sounds like a win-win for tech interviews. But, just like with any powerful tool, I imagine there are some pitfalls to avoid when using pseudocode.
Absolutely. There are some common mistakes that people make when they're using pseudocode.
Oh.
It's important to be aware of those to make sure you're using it effectively.
Okay. All right. Now I'm nervous again. What are those pitfalls and how can I avoid them?
Don't worry. I'll guide you through it.
All right. I'm ready. Okay. All right. Now I'm nervous again. What are those pitfalls and how can I avoid them?
Don't worry. I'll guide you through it.
Right. I'm ready.
So, pitfall number 1, being too vague.
Okay.
Remember, pseudocode should be high level, but it still needs to be clear enough that you can actually turn it into code.
Right.
It's like giving directions, You wouldn't just say, go north.
Right.
You got to give, specific landmarks, turns.
Yeah, no cryptic instructions. I could see how that would lead to a lot of frustration and wasted time. So what's the opposite end of that spectrum?
The opposite is being too detailed.
But
Don't get bogged down in the little tiny details of syntax or specific language features.
right.
Remember, pseudocode's about the essence of the logic,
Okay.
not getting lost in the weeds.
So it's all about finding that sweet spot
Yeah.
between too vague and too detailed.
Exactly.
Okay. All right. What other traps should I be aware of?
Another common mistake is ignoring edge cases.
Oh, okay.
Even in pseudocode, you need to think about those unusual scenarios, the unexpected things that might, break your algorithm.
Yeah.
Be proactive. Think about those potential problems before they arise.
So think like a tester.
Yes.
Try to break your own logic before someone else does.
Exactly.
Okay, that's a great tip. What else is there?
Number 4 is not considering efficiency.
Okay.
You don't need to go crazy with optimization at the pseudocode stage,
Right.
but it's good to start thinking about it from the get-go. Are there any obvious bottlenecks or redundant steps that you could streamline?
Okay. So even in the planning stages, keep efficiency in the back of your mind. Don't just assume you'll figure it out later.
Hmm.
What's the last pitfall to watch out for?
Keep your pseudocode updated.
Oh, okay.
If you make changes to your actual code, make sure those changes are reflected in the pseudocode.
Right.
Keep them in sync.
Yeah.
So it remains a valuable tool, an accurate representation of what your code's actually doing.
That makes perfect sense. Otherwise, it just becomes outdated and it loses its value as a reference. It's like having a map with the wrong roads on it.
Exactly.
Okay. So now that we know the pitfalls, are there any tools or techniques that can make writing pseudocode easier?
Absolutely. You can always use a simple text editor, but there's some cool tools out there to enhance your pseudocode workflow.
Ooh, tools. I'm
Yeah.
always up for exploring new tools.
hmm
What are some of your favorites?
Well, for the visual learners out there, flowcharts can be incredibly helpful.
Okay.
It's a way to visually represent the flow of your algorithm, alongside your pseudocode.
Yeah.
And there are lots of online tools that make creating flowcharts really easy.
Yeah, I love visual aids. I mean, it's much easier for me to understand something when I can see it visually.
Of course. And then for people who like to brainstorm,
Mm.
organize their thoughts before diving into the actual writing, you know, mind mapping software can be a game changer.
Okay.
It's like free-flowing brainstorming, but on a digital canvas.
Hmm.
You can explore different paths, different connections before you actually settle on the pseudocode.
Yeah, that sounds perfect for, people who like to map out their ideas and see the big picture
Yes.
before they get into the detail.
And of course, for teams,
Hmm.
collaborative platforms are key.
Yeah.
They let everyone work on that pseudocode together in real time.
Oh, nice.
It really fosters that shared understanding.
So crucial for teamwork. No more emailing different versions back and forth.
Exactly. You got it.
All right, what else is out there?
Believe it or not, some IDEs actually have built-in support for pseudocode.
Wow. So like specialized software for pseudocode.
Yeah, they have features specifically for writing and managing pseudocode.
Sure.
And then there's a technique called comment-driven development,
Okay.
where you basically write your pseudocode as comments directly in your code file.
Oh, interesting.
It's a way to tightly integrate your planning with the implementation.
So it's like you're weaving your thoughts directly into the fabric of the code.
Exactly.
Pretty cool. Speaking of thinking, it's important to understand that pseudocode is really connected to this broader concept of algorithmic thinking.
Absolutely.
Okay. Now I've heard that term before, but I'm not entirely sure what it means. Can you explain algorithmic thinking and how it relates to pseudocode?
Sure. Algorithmic thinking is the ability to break down a problem into a sequence of steps
Okay.
that can be followed to achieve a specific outcome.
Oh, wait.
It's like having a mental recipe for solving problems.
So it's like thinking like a computer,
Yes.
breaking down those, sometimes overwhelming tasks into smaller
Yes.
and more manageable steps. And pseudocode helps us do that.
Exactly. Pseudocode it's like a training ground for algorithmic thinking.
Oh, okay.
It forces you to think sequentially,
Okay.
consider different conditions, and make sure your steps flow logically from one to the next.
So it's like a mental workout for your logic muscles.
Exactly.
Okay, I like that.
Yeah.
Now, as you write pseudocode for different problems, do you start to like notice recurring patterns?
Absolutely.
Like you start to develop this like mental library
do.
of problem-solving techniques
We do.
that you can then apply to new challenges.
Yeah, it's not just about solving that one specific problem.
Right.
You're building up a toolbox.
Right, a toolbox of strategies that you can pull from.
And the process itself
Mhm.
sharpens those logical thinking skills.
Okay.
You have to think critically, consider all the different possibilities, and just make sure your steps are clear.
So it's like training your brain to think more systematically, more logically. No more jumping to conclusions
Exactly.
or getting lost in the chaos. All right, I dig it. Now, another benefit I've heard of using pseudocode is that it encourages abstraction.
Yes, absolutely.
So you can focus on the core logic of your solution without getting bogged down in the specifics of a particular language.
Right. Seeing the forest for the trees.
Yeah, exactly. Understanding the big picture without getting lost in the details.
And it promotes modularity.
Okay.
Breaking down your solution into functions or modules, you're practicing good software design principles. Your code becomes more organized, reusable.
So pseudocode isn't just about, writing better code. It's about thinking better.
Yes. And you know what? It's not limited to programming.
Oh, really? I thought it was just a programmer's tool.
Yeah.
Tell me more about how it ventures beyond the world of coding.
Well, for example, database design.
Okay.
You can use pseudocode to plan out complex database operations, how to connect to the database, what data to retrieve, how to process the results.
So it's like writing a recipe for the database to follow.
Exactly.
Right.
And machine learning.
Oh, wow. Yeah.
Huge in machine learning. Pseudocode is incredibly valuable
Yeah.
for representing those complex algorithms. So, for example, you could use it to outline the steps involved in training a neural network.
That's amazing. So even in those like cutting edge fields like AI,
Yeah.
pseudocode has a role to play.
Absolutely. Game development,
Okay.
you can use it to outline the logic of the game, how it responds to player input, how the game state changes, how different elements interact.
So it's like writing the rules of the game, but in a language that both humans and computers can understand.
Exactly.
Okay. Okay. What other examples are there?
Web development.
Okay.
You can plan out, the logic of web applications,
Okay.
how user registration works, how data is validated, how different parts of the application talk to each other.
Wow. So pseudocode is like this universal language for problem solving.
It is.
It's not limited to any one specific field. That's pretty incredible.
And it's great for documentation.
Oh, okay.
Yeah.
Yeah. Documentation is something that I've always struggled with a little bit.
Mm-hmm.
How can pseudocode make that better?
Well, for starters, it can provide like a high-level overview
Plus-
of what a complex piece of code actually does.
Right.
So instead of just diving straight into the code, you can kind of understand, the logic, the purpose
Okay.
in plain language.
So it's like an executive summary for
Yeah.
your code.
Yes.
Okay.
Making it easier for people or even yourself to understand the big picture.
And for those, tricky algorithms, I imagine pseudocode is a lifesaver. Because sometimes the code itself can be really, really difficult to decipher.
Absolutely.
But pseudocode can kind of break it down into those more digestible steps.
Yes.
Make it much easier to wrap your head around.
It's like having an interpreter
Yeah.
for your code.
Much less intimidating that way.
And keeping your pseudocode as part of your documentation, it can actually provide like a record of your thought process.
Oh, okay.
So if somebody else needs to understand your code or modify it later on,
Yeah.
they can actually see how you arrived at that solution.
So it's like leaving breadcrumbs for future developers.
Exactly.
No more head scratching, trying to figure out what you were thinking, 6 months ago.
And it can be a huge help when it
Mhm.
comes to maintaining or updating existing code. If you need to make changes.
Referring back to that pseudocode can help you understand the logic and make those changes safely.
So it's like having a roadmap for navigating the complexities of somebody else's code.
Exactly.
Okay. Now let's talk about how pseudocode fits into the world of agile development.
Right.
Agile's everywhere these days.
Yeah.
How does pseudocode play a role in that fast-paced?
It's very valuable in Agile
Okay.
because, in Agile you have these short development cycles called sprints.
Right.
And pseudocode can be super helpful during sprint planning.
Mm-hmm.
It helps break down those user stories, which are basically just descriptions of what the user wants
Right.
into more detailed tasks.
Okay.
So the team has a clearer understanding of what needs to be done.
So it's like creating a to-do list for the sprint, but with a focus on the logic and the steps involved in each task.
And Agile often involves pair programming.
Where, two developers are working together.
Yeah.
Writing that pseudocode together can help ensure that they're both on the same page before they even start writing any code.
Yeah, two heads are better than one, especially when you're tackling like complex logic. So pseudocode helps facilitate that
Yes.
collaboration.
Collaboration and alignment.
Okay.
Now, during code reviews, which are, a big part of Agile, including pseudocode in your submissions, can really help the reviewers understand your code quickly.
Okay.
It streamlines the process, leads to more effective feedback.
So it's like you're providing a guided tour of your code.
Yes.
Making it easier for them to follow your thought process. I like that. All right. Anything else?
One more thing, refactoring code.
Okay.
Improving the structure, the design, without changing how it works.
Right.
Pseudocode can be a great tool for planning that out.
So it's like drawing up a remodel plan before you start tearing down walls in your code.
Yes.
Makes a lot of sense. We've talked a lot about how pseudocode helps experienced developers, but what about people who are just starting out? How can pseudocode help them learn and grow as programmers?
That's a great question. It's a fantastic tool
Okay.
for both teaching and learning how to program.
Okay.
For teachers, it allows them to introduce new concepts without getting bogged down in the syntax of a specific language.
Right.
Students can grasp the core logic and then worry about the language details later.
It's like learning the rules of the game before you start playing. You get a feel for how things work before you dive into, all the nitty-gritty details.
Exactly. And for learners, it provides a safe space to practice. They can experiment, make mistakes without the fear of syntax errors.
Yeah.
They can focus on the logic, the steps, and, not worry about breaking things.
It's like having training wheels for your code. You can build confidence, and you can get a feel for how things work before you take on the full complexity of actual code.
Mm-hmm.
And pseudocode is often used like in textbooks or online courses, right?
Yes.
To explain algorithms in a way that's not tied to a specific language.
Right. It's that common language.
Okay.
Anyone can understand.
So it's a great equalizer.
Exactly.
It brings everyone to the same starting point.
Yeah.
So they can focus on those core concepts without getting lost in language-specific details.
Exactly. And even for people who are, learning on their own, writing pseudocode can be a really powerful technique. When you're struggling with a new concept, writing it out in pseudocode can help you solidify that understanding. Make sure you really get it.
Yeah. I remember when I was first learning to code, pseudocode really helped me break down those, sometimes intimidating concepts into more manageable chunks. It was like having like a tutor, guiding me through it step by step.
Yeah.
And that actually brings us back to the main point, this whole deep dive.
Right.
Pseudocode is so much more than just like a stepping stone to writing code.
Exactly.
It's really a powerful tool for clear thinking, problem solving, and communication.
Yes.
And it's applicable far beyond just programming.
Absolutely.
It's like a secret weapon for anyone who wants to become a better thinker and problem solver.
Absolutely.
Regardless of their field.
You got it.
Honestly, I'm blown away. I came into this thinking pseudocode was just this, technical thing for programmers, but now I see it as this incredibly versatile tool for clear thinking. Like you said, it's a secret weapon for problem solving, no matter what you're doing.
It's exciting to see how that light bulb moment happens, isn't it?
Yeah. Pseudocode's all about taking those like swirling thoughts in your head and turning them into a clear, actionable plan. And the fact that it's not limited to just programming is mind-blowing. I'm already thinking about how I can use it to plan, my next big project at work,
Yeah.
or even just organize my grocery list.
I love it. Don't limit yourself
Yeah.
to the examples we've talked about. The power is in that adaptability.
Yeah.
Think about how you can apply those principles of breaking things down, thinking logically, to any challenge you face.
So just to recap, what we've learned today, pseudocode is this incredible tool that helps us clarify our thinking, communicate more effectively, plan better, save time, and just become better problem solvers. It's like a Swiss Army knife for our brains.
I love that. Couldn't have said it better myself.
But before we wrap up, I have one last question for you. What's one final thought-provoking challenge that you'd like to leave our listeners with? Something to really, get those mental gears turning.
Okay. Think of a task that you do every single day. Something that might seem, mundane or routine. Could be anything. Making your morning coffee, folding laundry, commuting to work.
Okay, I've got one in mind.
Now, try writing pseudocode for that task.
Oh.
Break it down into the individual steps. Consider the different conditions or variations, and see if you can capture the logic of that seemingly simple activity in a clear, structured way.
Interesting. So even something as simple as making coffee
Yes.
can be broken down
It can.
into this logical sequence of steps.
You might be surprised by the hidden complexity in those everyday tasks.
Yeah.
And how much clarity you can gain by applying these principles. So give it a try. See what you discover.
That's a fantastic challenge. I'm definitely going to give it a go. Who knows? Maybe I'll finally optimize my morning routine
There you go.
and gain a few extra minutes of sleep. Thanks for joining us on this fascinating exploration of pseudocode. Until next time, keep those minds curious, those algorithms flowing, and remember, even the most complex challenges can be broken down into simpler steps.
Happy problem solving.
Honestly, I'm blown away. I came into this thinking pseudocode was just this, technical thing for programmers, but now I see it as this incredibly versatile tool for clear thinking. Like you said, it's a secret weapon for problem solving, no matter what you're doing.
Yeah, it's exciting to see how that light bulb moment happens, isn't it? Pseudocode is all about taking those like swirling thoughts in your head and turning them into a clear, actionable plan.
And the fact that it's not limited to just programming is mind-blowing. I'm already thinking about how I can use it to plan, my next big project at work or even just organize my grocery list.
I love it. Don't limit yourself to the examples we've talked about. The power is in that adaptability.
Yeah.
Think about how you can apply those principles of breaking things down, thinking logically, to any challenge you face.
And so just to recap, what we've learned today, pseudocode is this incredible tool that helps us clarify our thinking, communicate more effectively, plan better, save time.
Yeah.
And just become better problem solvers. It's like a Swiss Army knife for our brains.
I love that. Couldn't have said it better myself.
But before we wrap up, I have one last question for you. What's one final thought-provoking challenge that you'd like to leave our listeners with? Something to really, get those mental gears turning.
Okay, think of a task that you do every single day.
Yeah.
Something that might seem, mundane or routine, could be anything. Making your morning coffee, folding laundry, commuting to work.
Okay, I've got one in mind.
Now try writing pseudocode for that task.
Oh.
Break it down into the individual steps, consider the different conditions or variations, and see if you can capture the logic of that seemingly simple activity in a clear, structured way.
Interesting. So even something as simple as making coffee
Yes.
can be broken down
It can.
into this logical sequence of steps.
You might be surprised by the hidden complexity in those everyday tasks and how much clarity you can gain by applying these principles. So give it a try. See what you discover.
That's a fantastic challenge. I'm definitely going to give it a go. Who knows? Maybe I'll finally optimize my morning routine
There you go.
and gain a few extra minutes of sleep. Thanks for joining us on this fascinating exploration of pseudocode. Until next time, keep those minds curious, those algorithms flowing. And remember, even the most complex challenges can be broken down into simpler steps.
Happy problem solving.